Hey guys, today we are talking about division again. Just like we did last Friday, we are dividing some polynomials, but we're going to use what's called synthetic division, which is actually much simpler than dividing just by using long division. So it works really quickly, but there is some caveats. We have to make sure that the number we're dividing by is just very simply a two terms, and it's just like this, like x minus 5 or x plus 3 or just x and another number. And if we're just divided by something like that, we can use synthetic division. So this is a great way to check if something's a factor or to divide really quickly. So let me show you how this works. And it works really, really simply. Okay? Let's take this equation right here. What we're going to do is we're going to put it in this pattern. We're going to take each one of my numbers here, like this one is a 1, 2, -8, -35. We just write those numbers out. Make sure that's in order and there's no gaps, like it goes x cubed, x squared, x35. If there's any gaps, we have to put a placeholder 0. Then we're going to draw in the opposite of the number that's beside the x here. Anyways, let me show you. So it goes like this. So for this problem, we have no gaps, so I'm just going to write all of these in. I'm going to write 2, -6, 1, because there's a 1 right here, -3, -3. And so those are all of my numbers for the top right here. And then I'm going to draw a little backwards L, a little box right here, and I'm going to put the opposite of my number that's on the bottom. So here I have x minus 3. So what goes in here is called the 0, right? The opposite of that factor. And if x minus 3 is my factor, if we set it equal to 0, my 0 would be +3. So we put a +3 right there. Okay? Now, then it's super easy division. Watch what happens. We're going to draw a line right here. And the first thing we're going to do is bring down this 2. So we're going to bring down this 2. And then, if you ever get lost, look back at your instructions here. So we bring down our first number, and then we're going to multiply to the first number, then add, multiply, add, and the last one, that last one is going to be my remainder. So it goes like this. So we're going to multiply first. We're going to go 3 times 2, and we're going to write it right there. Okay, so 3 times 2 is 6. Then we're going to add. -6 plus 6 is 0. Then we're going to multiply. 3 times 0 is 0. Then I'm going to add. 1 plus 0 is 1. Then I'm going to multiply. 3 times 1 is 3. -3 plus 3 is 0. Then I'm going to add. Then I'm going to multiply. 3 times 0 is 0. And then -3 plus 0 is -3. Okay, so here's how this shakes out. This last number, this is my remainder. So whatever you have as our very last number at the end, that's your remainder. And then we just go upwards from there. So this next number is going to be my whole numbers. Then my next number is going to be my x's. And then we have my x squareds, and then my x cubed. We should, if we did this right, be at 1 less, x cubed, 1 less than what we started, which was x4. Okay? So, there you go. So we can write out my new equation. My new equation is going to be 2x cubed. Then I have no x squareds. I have 1x. I have no whole numbers, but then I have a remainder of -3. So we're going to write plus -3 over, and then we're going to put it over what I'm dividing by, right? And I'm dividing by that x minus 3 there. So we'll just write x minus 3. And then this is going to be my solution, right? Here's my answer plus my remainder. And just like that, we were able to divide. Super simple. All right, let's try this again. Number 2. So number 2, we have -x cubed plus 3x squared plus x. All right, now we're going to write out our numbers. So we have a negative invisible 1 right there. So that's my first number, -1. then I have a 3, then I have an x, which is going to be a 1 right there. And then you'll notice I'm missing my whole numbers. And since we're missing that, we're going to go ahead and put a 0 right there as a placeholder. So I'm going to put a 0 there as a placeholder. I'm going to build my little backwards L. And the number that I put in there, remember, is the opposite of the number we're dividing by. So we have x minus 2 here, so we're going to put x plus 2 right there. We're going to draw my line, and now I'm going to bring down my first number. So we're going to bring down -1, and then we're just going to multiply, add, multiply, add, multiply, add, right? So we're going to go 2 times -1 is -2. 3 plus -2 is 1. 2 times 1 is 2. 1 plus 2 is 3. 2 times 3 is 6. 0 plus 6 is 6. So remember, this is my remainder. Right? Number 6 is my remainder. This is my whole number. This is my x's. And this is my x squared. Once again, it's 1 less than where we started. So we're going to be at, here we go. My final answer is going to be -1x squared plus 1x plus 3 plus my remainder over what we were dividing by originally, which was x minus 2. Okay? So that's really all there is to it. Just follow those steps and you divide really easily. Okay, let's take a look now at number 3. Okay, so we have a factor theorem. A polynomial has a factor of our factor if f of k equals 0. In other words, the remainder is 0. So after you, pretty much if you divide a number and the remainder is 0, that number is a factor. Like in simple terms, like 8 divided by 2 is 4 with no remainder, so 2 is a factor of 8, right? So if we divided this by x minus 2 and there was no remainder, it would be a factor. So let's see if x minus 2 is a factor. So we're going to write out our numbers. So remember, invisible 1 right there. So we're going to have 1, 2, -4. Build my little half box here. Put +2 in the box. Draw my line. And then bring down our first one. Bring down 1. So we're going to go 2 times 1 is 2. Add those together. 2 times 2 is 4. 2 plus 2 is 4. 2 times 4 is 8. And then -4 plus 8 is a +4. So this is my remainder. So here's what my answer would be. It would be 1x. It would be 1x plus 4 plus my remainder of 4 over what I'm dividing by, which is x minus 2. So obviously there's a remainder. So it's asking, determine whether it's a factor. Well, it's not a factor because there is a remainder. So it's going to be no, not a factor. All right, so this one's not a factor because there's remainder. Let's take a look here at number 4, see if that changes anything. Okay, so number 4 says determine whether x plus 5 is a factor. So we're going to write this out here. However, take a notice. Look at this. We go x to the 4th, x cubed, x squared, and I'm missing one right here. So we need to put in a placeholder of 0x right there. So whenever we write my list, make sure you put that placeholder in there. Okay, so here we go. It's going to have 3, 15, -1, 0, 25. Draw my little backwards L. Put my backwards of that in there. So put a -5 in there. And then we're going to draw my line. We're going to bring down my first number. So we're going to bring down my 3, and we're going to multiply. -5 times 3 is -15. 15 plus -15 is 0. -5 times 0 is 0. -1 plus 0 is -1. -5 times -1 is a +5. 0 plus 5 is 5, and -5 times 5 is -25. And so 25 plus -25 is 0. Okay, so remember this last one is my remainder, and it's 0. So there is no remainder. So whenever I write my answer here, we're going to have, remember, it's going to go like this. We're going to have, this is my remainder. These are my numbers. this is my x, this is my x squared, this is my x cubed. So whenever I write my answer, it's going to be 3x cubed, no x squareds, minus 1x, plus 5, and then there is no remainder, so that's my answer. And it's saying determine whether it's a factor. Okay, easy stuff. Yes, it is a factor because there is no remainder. All right? Okay, last one. Take a look here, number 5 with me. Kind of a long one. Number 5 says, show that x plus 2 is a factor, then factor and solve. So let me show you how this works. We're going to take this x plus 2. So we're going to go, okay, we have negative 2 in the box, right, in the half box. And then we're going to write this out. Look and see if we need a placeholder 0. It goes x to the 4th, x cubed, x squared, x, whole number. So no, I don't need a placeholder 0. Everything is there. So I'm going to write 1, 5, 5, negative 5, negative 6. I'm going to draw my line, and I'm going to then bring down my first one. Then we're going to go negative 2 times 1 is negative 2. 5 plus negative 2 is 3. Negative 2 times 3 is negative 6. 5 plus negative 6 is negative 1. Negative 2 times negative 1 is 2. Negative 5 plus 2 is negative 3. Negative 2 times negative 3 is going to give me positive 6. And negative 6 plus 6 is 0. So there is no remainder. So it is a factor. So then we can label. We say, okay, that's my remainder. This is my, then that makes this my whole number, my x's, my x squared, and my x cubed. Not x to the 4th, x cubed. Okay, so we can write out what this factors out to be. We have a factor of x plus 2 because it is a factor. And I'm also going to have a factor of 1x cubed plus 3x squared minus x minus 3. Okay, then no remainder, and then it says, then factor and solve. So factor and solve, that means this also we're going to set equal to 0. All right, long story short, okay, we factored out our first one, we got x plus 2. Now, I'm going to need to factor out this x cubed plus 3x squared minus x minus 3. All right, so we're going to have to recall what we learned last couple of days, and to factor, how many terms do we have? We have 1, 2, 3, 4. We have 4 terms we're going to factor using difference of squares. I mean, not difference of squares, sorry. Factoring by grouping. So we're going to group the first 2 here and group the last 2. So we'll pull out an x squared, and that'll leave me x plus 3. On the other one, I'll pull out a negative 1, and that'll leave me with an x plus 3. Then we have these x plus 3's in common, so I can bring those to the front. So I'll have x plus 3 times x squared minus 1, and then we'll put back my original factor. So we'll put back the x plus 2 in front. Now we check and see, can I factor this anymore? And the thing is, this x squared minus 1 is a difference of squares. X squared is a perfect square. It is x squared, and 1 is a perfect square. It is 1 squared. So if that's a perfect square, difference of squares, we can write that as x plus 1 times x minus 1. So we're going to have x plus 2 times x plus 3 times x plus 1 times x minus 1. So here are all my factors. These are still going to be set equal to 0, so we can still solve this. We can set each one of these equal to 0 and get my final solutions. We can go x plus 2 equals 0, x plus 3 equals 0, x plus 1 equals 0, and x minus 1 equals 0. So we're going to get an answer of x equals negative 2. We're going to get an answer of x equals negative 3. We're going to get an answer of x equals negative 1. We're going to get an answer of x equals positive 1. So here are all my solutions for this. Here are all my factors, and that x plus 2 was indeed an original factor. All right, guys, practice your synthetic division. Make sure that you follow the steps listed on the front page, and hope it works out for you. Let me know if you have any questions. Thanks, guys.